So my preferred mode of presenting is with a whiteboard. I do use the slides when I have the nutrient data because I think it's pretty damn compelling, and I think it's a good way of presenting it. But for practical stuff, I like drawing pictures. I think I've got an hour, which is not much time to convey what I would like to convey, but I definitely want to start with questions. I'll make a jot note here quickly if people have any quick questions you think you might want me to focus on or answer.
You might be going to cover this, so whether it's necessary or relevant. Do you have a metric or a way of quantifying life in the soil?
Okay. I'm not answering questions now. I'm just putting them down, and I'm going to weave them into the presentation. But I'm going to change the presentation based on what your questions are. So if there's things you're curious about, this is the how-to point. The previous thing was the vision and the mission and the science. And this is the how-to if you're a farmer.
The impact of the aluminum and the barium and the stratospheric injection. No matter how hard we work, we can't control some of those parameters. How do we offset the impacts?
Yep.
Well, okay, so I think that going off of how to measure soil life, you're not going to like this, but for 95% of the acres in the United States, it has to at some point be turned into a little bit of a liturgy, to use your religious analogy.
Thank you. Nicely done. No one's used liturgy with me before. That's great. Yes.
It has to be liturgical what you do, because we can't go out and baby every acre. Maybe we can, but we need to have something that's replicable at a large scale to actually make the impact in the industry that we need to see happen in order to get the nutrient-dense foods across the board. So what are the steps to how to get the soil life to improve?
Yep.
How to measure it, and then the next thing is how do you get it?
That's exactly my agenda.
Okay.
I'm not even going to write that down because that's exactly my whole hour is that.
We know nutrients important, but we know commodity markets don't represent that or embrace it.
Yep.
How do farmers leverage that to make a profit and really start to get a better price for what we do?
How about just profitability? How about it's just about bottom line money in the bank at the end of the year is what really matters, not how much you spent or how much you made, but how much you've got at the end of it. Can we agree that's net is what matters, not gross?
On the money level, I'd love to hear about some grants that you might know about. I help farmers, so like something that I could talk to my clients about, funding that I might not know about for implementing these practices.
I'm not the right guy to talk about grants. I've never gotten one. I never asked for one. I know there's a bunch of soil health stuff that's out there. EQIP is it called?
Yeah.
I think EQIP is pretty damn legit. And for farmers on scale, I think it's actually totally plausible. Like $23 an acre, if you got 2 acres, who cares? $46, like it's not worth the hassle of filling out the form. But if you're doing 1,000 acres, I think some of the EQIP stuff is really, really exciting. And if you got, yeah, I think the NRCS is an amazing entity, and every county has a county agent, and they're supposed to. Like, I think if you, NRCS and the EQIP stuff, I think is a great angle to look through. Yes. But I don't know.
Thank you.
I've only heard. I know what I've done. I haven't done that. Yeah. Okay.
So ultimately, we make our money selling meat.
Yep.
And as you guys are looking to develop systems to test that,
Yep.
what is available currently for us to test the nutritional value of our products, and then how affordable or reasonable is it for us to even use those resources?
Or is it necessary?
Yeah, or is it necessary?
There's always going to be people trying to sell you stuff, and now there's people trying to sell you lab work, which I don't think is necessary. But I'll talk about what's there.
Yeah.
But I'm a farmer first, and any money I don't spend is money I didn't have to earn. So the first thing is don't spend unless you got a really good reason. And I mean, labs are nice, but yeah, okay. Anything else? Okay. I like to start my presentations with a stick figure. Who can be the first person to figure out what it is? Little cheat. What's this? Ready? Oh. I call it a plant. Okay, so basics. Most people will agree that most plants are green. Yeah? Most people will agree that plants are green because they have in their leaves these things called chloroplasts, in which occurs this thing called photosynthesis. So far, so good. The recipe for that process is water plus carbon dioxide plus sunlight equals oxygen and sugar. No complaints yet. We're about to walk you down the garden path. So, most people will agree that the plants eject the oxygen that's made in the leaf out of the leaf into the atmosphere. I think I learned it in 9th grade. What I didn't learn in 9th grade was that in nature, and the caveat here is in nature, plants inject a majority of the sugar they manufacture in the leaf into the soil. The sugar goes from the leaf through the stem, through the roots, into the soil. And I think I said this earlier, but that is because on none of the first 6 days did God invent fertilizer. And there's this thing called evolutionary biology. Anybody ever heard of evolutionary biology? It's like a kind of a who came first thing. The bacteria and the fungi came first. They evolved the plants. So basically there was a long time when there was no plants on Earth. And the microbes said, hey, you know, wouldn't it be great if we could occupy this land and be fed to do a better job of digesting the minerals so we could flourish more well. So they took the phytoplankton that were living in the ocean, and they, you know, basically evolved leaves around them and created this kingdom, we now call it a kingdom, whose job from their perspective was to feed them. So the microbes evolved plants to make sugar to feed them so they could digest the soil and reproduce. Order of operations, who came first, who's in charge. So there's this zone, people may have heard about it, called the rhizosphere. It's this area around the plant root where the vast majority of life in the soil resides. You may have heard this story about like 1 teaspoon of soil has more microbes in it than there are humans on the planet. That, of course, is soil, not dirt. So yes, in a teaspoon of soil, there is more microbes than there are humans on the planet, but not in a teaspoon of dirt. Dirt is soil without life in it, or is a continuum, so much less. So here we have soil. This area that exists around the plant roots is where the vast majority of life in the soil resides. And over here, we have dirt, where you don't have a lot of life. So this looks a little bit messy. I'm sorry, I'm in a rush. The point I want to make is, from how I understand it, it's completely irrelevant if this is a potato, a rye, an apple, echinacea, cucumber. We've been taught that broccoli needs this, and corn needs that, and potatoes need this over here. From a foundational standpoint, if you're working with nature, the first thing they need is a well-functioning microbiome. Only when their gut flora is happy and healthy and flourishing are they going to be well. And actually, well, minor side note, I won't go there yet. I'll go there. I'll wait a minute. Yeah, so I mean, the foundational point I like to make I call this conversation principles of biological systems. The basic point is only when the bottom of the food chain is functioning well is the middle of the food chain going to function well. We think of the microbes as the bottom, the plants as the middle. In some textbooks, it's said that the plants are the bottom of the food chain. Has anybody ever heard that? The plants are the bottom of the food chain and the animals are the top? Like we forgot. Yes, this guy's nodding. He works at a university. Yeah, right. Like it's literally taught to people that the plants are the bottom of the food chain. Like we forgot the microbes. People know about what percentage of the soil, of the cells in your body are human? Anybody know? Less than 10% of the cells in your body are human. That means then logically that 90+% of the cells in your body are not human. Who's been taught about kingdoms? Like the plants are here, the animals are there, the bacteria, the fungi, the blue-green algae, and there's archaea, I'm not quite sure what they are, and viruses. Who's heard about the kingdoms? Anybody hear about the kingdoms? Show me a plant that has only plant cells in it. Show me an animal that has only animal cells in it. If you can't have an animal with only animal cells, then this concept of a kingdom is a flawed concept. I mean, it's kind of a nice framing to begin to tell a story. I propose that we're actually ecosystems. We are all kinds of hundreds and thousands of species living in symbiosis with each other. Each one of our bodies we're carrying around is a massively diverse ecosystem. And the real question is it a pathogenic ecosystem? Does it have cancer? Does it have diabetes? Is it eating itself alive? Is it about to die? Or is it a symbiotic ecosystem? It's flourishing and vital and expansive. Same for plants. Your plant can't grow by itself. We oftentimes make the mistake of thinking that what we're doing is growing plants. Like, there's your first mistake. If you think you're raising rye, or you're raising corn, or you're raising apples, or you're raising potatoes, you need to have another think. You're never going to succeed if that's what you think you're doing, because you can't cause potatoes to flourish without, at the foundation, a well-functioning microbiome. So I want to emphasize the point that it's, at least for me, if we don't start with how do you get a well-functioning microbiome, you're never going to have healthy plants. Does that sound somewhat logical? Okay, so this is basically my, what did she call it? Liturgy. This is it. What are the environmental conditions necessary for the bottom of the food chain to flourish? What do microbes need to be happy? Because if any of those things isn't present, you will have all kinds of symptoms of pests and diseases and failures to thrive, and you haven't identified what the root cause is. And until you can identify the root cause, you can't solve the problem. And you're probably going to be sold something by somebody whose agenda is to sell you something. If you're ignorant and you don't know what the cause of your problem is, and somebody comes along and they've got nice marketing and they're charismatic and they're slick and they're friendly, and they tell you this will solve your problem, just sign on the dotted line here. In many cases, people do that. And we can see where we're at after 60 or 80 years of that, right? We're not improved. In many cases, we're struggling. So, okay, so what are the environmental conditions? This is rough, right? These are high tech. Air. Anybody have a cat? How old do cats get? 15, 18 years if you're lucky? Okay, so I'm going to do a thought experiment with you here. I'm going to start off with a plastic bag. And take that cat, anywhere between birth and 18 years. You can choose. 18 minutes, 18 days, 18 weeks, 18 months. And for just 10 minutes of that 18 years, at any point in the in that time frame, you take that plastic bag and you zip tie it over the cat's head. What are you going to have? You're going to have a dead cat. Okay, that's a joke. We're kind of laughing. Who's heard of a plow pan? Who has heard of a plow pan? If there's supposed to be billions of people in a teaspoon, and you can't stick your fingers into your soil past 2 inches down, I mean, you think Hitler was bad. How many quintillions, quadrillions, trillions of beings are dead because of how you've managed that ecosystem? Mass genocide has occurred. System regeneration can't occur because there's no air in your soil. Now I ask you, who has figured out how to sell air to farmers yet? Not many people. So who has an incentive in telling you? Not many people. Just because no one's telling you doesn't mean you don't need it. Aeration is so massively important. If you don't have air in your soil, your microbes can't breathe. If your microbes can't breathe, they're dead. If they're dead, they can't feed the plant. I'm sorry, did I say that part? On the first 6 days, God didn't invent fertilizer. The reason the plants make sugar and inject it into the soil is because the microbes evolved them to do that, because the microbes wanted to digest the soil, and the deal is the microbes feed nutrients up to the plant so it can grow and make more sugar and then feed more microbes. I think I skipped that part. Who's heard of Darwin? Anybody heard of Darwin? What's the one-liner associated with Darwin? Survival of the fittest. Anybody hear about that one? What's that? What's that? Particles? Survival of the fittest is a line that oftentimes people associate with evolution and Darwin, and it's kind of like in there in the zeitgeist somewhere, which we kind of take to mean I win by you losing. Survival of the fittest is that which is most fit reproduces and it competes and kills the other ones. That's kind of our white person's sort of colonizer mentality framing of the story, even though actually that wasn't what Darwin said and meant. He got taken out of context. I have one of my sort of like general rules of thumb, which is if nature does one thing and a human tells you something else, the human is wrong. So what I see happening here is nature covers herself in green to make oxygen, which she emits out into the atmosphere, and sugar, which she emits out into the soil. Now that is not strategic if you're a cucumber plant or a lettuce plant or a tomato plant to cover your body in green to make stuff that you emit out of the atmosphere if survival of the fittest means I win by you losing. That's a complete waste of energy. What nature's pattern seems to be is symbiosis. The plant succeeds by supporting all kinds of other beings around it, which in turn support it. Who's heard about this idea? If you're nice to people, they're nice back to you. Is success having a lot and a fence around your house and a bunch of other people around you that don't have much? Or is success being surrounded by people who are happy and loving? Actually, we make decisions in many cases for the first, but I think we all, in truth, know that the second is what success is. So symbiosis, I would argue, is the foundational pattern of nature. And this is the dynamic which occurs. And if you can't maintain aeration in your soil, all bets are off, right? If that cat lived for 18 years or would live for 18 years, and at age 3 months, the bag is tied over its head, it's not going to live for the rest of the 17 years and 9 months. So even if you have air in your soil for 3 months of the year, for 9 months of the year you don't have air in your soil, that microbiome is shut down, right? That is not what you need to have for life to flourish. So let's follow another one here. Well, I'll just use the example of what we do. I'll just as a common sense farmer, practical homesteader explanation of this. October comes, where I come, that's when frosts are happening and things are getting cold. We pull out all of our root crops, our carrots and our beets and our rutabagas and parsnips and turnips, and they all go in the root cellar. And then oftentimes that's the area where the garlic gets planted. Anybody here plant garlic in the fall? You plant garlic in the fall? So we're pulling out a 1/4 acre of root crops. We're putting in 1/8 of an acre of garlic. We usually mulch the garlic after we plant it. Anybody do that? Mulch garlic sometimes? No? Okay, well we do that. Mulch the garlic. Then November comes, the ground freezes, the snow comes, you start ice skating, sledding. December, January, February, March, the snow begins to melt. End of March, the ground is thawed. April, beginning of April, green things start to come out of the ground like garlic. So beginning of April, you pull some of that mulch aside. You look down, you see a couple piles of earthworm castings. You reach down, you pick up a handful of soil. Smells like soil. You go over 5 feet to the area where you didn't plant the garlic, and it's April, and it's dry, and it's windy, and the soil's not soil, it's dirt. It's cracked. Anybody ever seen that? One spot, another spot, right next to each other. One had earthworm castings, one you could put your hand in with soil, one was tight and no air, dirt. They both went through the same winter? Yeah. What caused the difference? Food. Guess what? Microbes like to eat. You got a cow? Don't feed her for a couple weeks. Where I live, like I said, when it gets to be October, the leaves are gone, there's nothing green growing for a good 6 months. If it's the green that's making the sugar that's feeding the soil life don't all, hop a plane to Florida for the winter. They're stuck and they need to eat. That's why we put our root crops in the root cellar and we can our tomatoes and juice and we freeze our vegetables and meat and dehydrate the tomatoes or whatever it is, right? We stockpile food in the winter so we can keep eating because all you can pick in the wintertime is eggs and milk. Maybe slaughter a pig. But for a bunch of the year, if you want to eat, you got to have it stockpiled. So what's stockpiled food? That's organic matter. That's mulch. That's cover crops. That's living roots. Where in nature do you see bare soil? Not where she's flourishing. If you're managing your land in such a fashion as for the soil to be bare, and that which is covering the soil is actually food for the life, the act of bearing the soil, you could say that Mother Nature is a woman and you are violating her by ripping her clothes off, right? That would be one way to look at it if you want to get real personal. Like disrobing your mother is not a proper thing to do. And yet we're trained that it's the way you farm properly is you can see the dirt in between the monoculture rows. We have this whole mentality of what's proper. If your objective is to maximize money from the farmer to the chemical salesman, then 100% this is proper. But if your objective is to optimize system function, you need to understand why nature does these things. And even though your neighbors might make fun of you and give you a hard time, the question is the opinion of your neighbor more valuable than your relationship with the divine? If you're violating nature on an annual basis by your practices, what matters more? It's difficult. But anyway, so keeping the life in the soil fed is foundational. You have to have green leaves making sugar and or dead leaves, plants, straw, hay, whatever, on the ground in nature. That's what causes soil to be soil, is cover. So air, food, The next one is water. Again, who's got kids? Don't water them just for 1 week out of 52. I mean, they got water for 51 weeks out of 52. A week off should be fine, right? Toughen them up. Who's ever thought that when it was the summertime and they, I'm not sure if you guys have these like tomatoes like on scale where people have these raised beds and they have black plastic and there's a line of drip tape that goes down the middle that's right where the plant comes in, and it's July or August and it hasn't rained in a while. There's a tractor path in the middle, of course, which you've got to plow, till to keep the weeds down because the weeds are bad. But if you take your hand and you rip a hole in the black plastic, it's powder under there. Anybody ever done that? Noticed? As above, so below. If there's 5 foot of tomato plant above ground, there should be 5 foot of tomato plant below ground. You make the mistake of thinking you're watering the plant. Huh. Again, you think you're growing plants. There's the mistake. What you're doing is supporting an ecosystem for life to flourish. In any place where the soil's dry, again, genocide. Mass die-off has occurred because your stewardship of the land has been insufficient. It's your responsibility to care for that land you have stewardship of. And maintaining moisture in that land is foundational for maintaining life in that land. And it's only when you have that well-functioning microbiome that that plant can feed the microbiome and the microbiome can feed the plant. Okay, I've got 4 kids. I've been in the presence of a pregnant woman now a few times. I know a couple things. One of them is when a pregnant woman is hungry, there is nothing more important than feeding her. As a husband, it is my responsibility to provide for her, care for her, ensure she has what she needs. That's my responsibility. Who's ever realized that a tomato plant that's filling fruit has the nutritional needs of a pregnant woman? Right? What do they say in the olden days? For every child, a tooth. Right? When women would have 6, 8, 10, 12 kids, and they'd start to have the teeth fall out. Because when you're pregnant and you're not getting into your body what your baby needs to be formed, nature has evolved a system which says you are less important than the baby, and it sucks what the baby needs out of your bones. People heard about this? Know about this? So what does the tomato plant do? When you, as a bad husband, have created dirt, dry soil, dirt, where the soil life is unable to feed the mother, is she sacrifices her body. She literally sucks the juice out of her body. We call it early blight. We've got a name for it. It's when the bottom leaves start to turn yellow and then turn brown and then fall off. Anybody ever seen that happen? And what you're told to do, either spray it because it's a fungal infestation or pull the leaves off. And then what happens? The next leaf starts to do it. Anybody ever been in like a hoop house in September or October where somebody's really lovingly taking care of the tomatoes and they're one big naked stem 10 feet up? That is not a sign of flourishing vitality. It's a water deficiency. She's sucking the potassium and magnesium, the electrolytes out of her leaves, the things she can afford. I mean, like the calcium is stuck in the cell walls. Can't pull that out, suck it up. But at least she can pull the juices out of the leaves to feed her babies. We're busy thinking we're raising tomatoes. That's the mistake. What we need to be understanding is that it's about creating a dynamic where the bottom of the food chain, life, is flourishing. Because when we do that, when we give life what she needs, when we support her, magic happens. Fecundity occurs. Like you put the plants in the ground, you make sure the basic stuff is there, take a nap, play with your kids. Like, because plants grow in nature, because she's got it figured out. All right, air, food, water. I'm afraid I'm running long and I don't have much time, so we're going to just move right along here. Well, let me just say one more thing. Like, is it like 100 miles east of here? If you drive and you stop right at the edge and you get out and you put your feet down, like the water comes up and down twice a day. How far away is that? Ish?
Yeah,
200 miles, wherever it is, that direction-ish, wherever east is. I'm actually not quite sure. It's too cloudy out to tell. You've heard about this idea? That right at the edge of the ocean, the water goes up and down twice a day? You've heard about the fact that it somehow has something to do with gravity and the sun and the moon? Everybody's okay with that concept? Pretty much everybody agrees with it? We call it the tidal force. Did you ever think about the fact that the tidal force applies on land too? Gravity is not just applicable in the ocean. Gravity is applicable on land also. So here's it. What's that?
So thank goodness.
Thank goodness. I'm talking about the gravity that goes up, though. Who has been in a seasonal stream, little like a creek, in July that's not flowing one day, and you go out the next day and there's a little trickle? Anybody, I'm seeing a couple nods, have ever been out in a seasonal stream in the middle of a drought, one day there's nothing flowing, and the next day there's a trickle, and the next day there's nothing flowing, and the next day there's a trickle, and like, what the hell's going on? It hasn't rained in a month. Yes? Some people have seen this? It's the gravity of the sun and the moon. It's the tidal force which pulls the water up from the water table through capillary action. This is how the trees in the forest and the fields stay green when it doesn't rain. They're literally watered from below when you have no plow pan. If you don't have subsoil compaction, literally the tidal force and capillary action, right now you've got a table and you put a napkin on the table and you put some water on one side and the water goes along. Capillary action. If there's just enough structure, it'll wick along. Capillary action and the tidal force will bring water down from the water table up to the root zone twice a day. This is how nature waters your plants. House plants, who knows about house plants? They like to be watered, right? You stick the house plant in that's how you're supposed to water house plants. That's how plants like to be watered. No infrastructure necessary. What else happens? As the capillary action raises the water from the water table into the subsoil, fills those pore spaces, all the microbes that have been down here breathing in oxygen and out carbon dioxide. If you were to close down this room really tight and stay here long enough, we'd all die because we'd run out of oxygen. You get a few billion people down there in every teaspoon of soil, and they're breathing in oxygen and breathing out carbon dioxide. They're going to run out of oxygen. Ever think about that one? Where's the AC system? Who's changing the air over? The tidal force. When the water comes up, fills the pore space, pushes the carbon dioxide out into the atmosphere where it's used by the plant to make sugar, and then the tide drops, and then the oxygen, which has been emitted out of the leaf, gets sucked down into the soil. Literally, the land breathes and is watered twice a day. I think that's completely magical. I mean, it's explainable through science, but it's so amazing. But if you engage in practices which mess up that soil structure, if you've got a plow pan, if you've been engaging in destructive processes, that's broken. It doesn't work. Okay, minerals. This was the thing that I did as an organic farmer that, like, you know when you're a farmer and you do something different and it actually works, and you actually see this thing like cause plants to grow different, you're like, what? You're sold all kinds of products and they kind of sort of, maybe if you look really close, kind of see something. And then you do something like, wow, that is a real thing. So for me, it was granite dust. I heard about remineralization. I heard about this concept that you need minerals. I went to my local quarry. There was a, I live in Appalachia, right? You guys live in Appalachia. It's up and down the whole coast, right? So this is a place where they had a saw and they were cutting into the side of the mountain 1-inch thick slabs, and they're making countertops. And just like sawdust, there's off wood, there's sawdust off a stone. And so I got the stone dust, and I had a shovel, and I put it in a couple old grain bags, stuck them in the back of the truck, and spread that stuff out on the field after we'd pulled the garlic before we put the fall brassicas in. And about, 6 weeks later, looking out the porch window, and there was this like sheen, an iridescent sheen in the brassica patch. And sometimes they'll have a nice look on them, but these guys were like, it was like neon light. Like, what the hell's going on down there? I'd forgotten that I put the rock dust down. It's like, what's going on in the brassicas? So there's this thing called enzyme systems and biochemistry. People may have heard about biochemistry. It sounds all fancy and complicated. It's like for the scientists. What percentage of the atmosphere is nitrogen? 78%. More than 3/4 of every breath of air you breathe is nitrogen. Who's the salesman who conned you into thinking that even though there's like 20,000 tons of nitrogen above every acre of land, that you got to buy it for your plants to grow? I mean, points, right? You got to give them points for creativity, for success. Like, give them points. How many trees in the forest are legumes? Not too many? Not too many. Who's adding nitrogen in the forest? Here's a factoid. We all agree that legumes have on their roots little nodules that azotobacter and rhizobacter live in where nitrogen fixation occurs. Yeah? Okay, because we agree that legumes have nodules in their roots where nitrogen fixation occurs, does not mean that's the only place nitrogen fixation occurs. Right? Because it can happen there, and does happen there, doesn't mean that's the only place it happens. There was a Russian microbiologist by the name of Krasilnikov who, I think it was some point in the 1970s, published the work. He looked at every single family of crop plants on the planet. Every continent, every tribe, every tradition, every family of crop plants on the planet. He was a microbiologist, and he'd identified species of microbes that worked with those plants to fix nitrogen. On none of the first 6 days did God invent fertilizer. Every plant has evolved a symbiotic relationship with nitrogen-fixing microbes. They don't all have legumes, have nodules, but they do all have the capacity to work with microbes that fix nitrogen. Krasilnikov was his name. You can go look it up if you want. This is 50-year-old science. It's written in Russian, though, so you gotta get a translation. But it is 50-year-old, peer-reviewed, published data. Now, you may not know, but some people who have bought a bean and pea inoculant and they put it on their, I don't know, soybean or their clover or their alfalfa seed, you may not know, but there's 500,000 pounds of an element called molybdenum added into bean and pea inoculant in this country every year. What's molybdenum? I'll tell you one thing, it's expensive. Molybdenum is not cheap. So what's the reason they're putting 500,000 pounds of it into bean and pea inoculant every year? Well, it's the core of this thing called the nitrogenase enzyme. So we've heard about enzymes. We're talking to farmers here. I like to say an enzyme is a tool that has a certain shape that you can use over and over again to put things together or take things apart. Anybody ever heard of a Phillips head tool? It's got a certain size and a certain shape that you can use over and over again to put things together and take things apart. How about a star-shaped tool? How about a 9/16? How about an 11 millimeter? Anybody? Yeah? You've heard of tools that have unique sizes and shapes you can use over and over again to put things together and take things apart. We call them tools. The scientists in biological systems call them enzymes, but they basically do the exact same thing. They have a unique size and shape. They're used over and over again to do a specific thing. They can only do that thing. What gives them their unique size and shape is the element at their core. Copper is 1.6 angstroms across. It has an icosahedral bonding geometry. Who remembers Tinker Toys? Remember Tinker Toys? You get that one thing with all the holes in it, and it's got the certain shape, and the sticks you put into it, they only can have a certain shape because of the shape of the thing at the beginning, at the middle. So a copper-based enzyme, copper has a certain size and a certain, it's 8-sided geometry or 12-sided geometry. So anything that's attached to a copper can only make a thing that's a certain shape. Does that kind of make sense? Molybdenum is the center of the nitrogenase enzyme. You need, wait for it, 1 pound per acre of molybdenum in your soil for all the microbes working with all the plants to fix all the nitrogen you ever would need. 1 pound of molybdenum in an acre is all you need at the center of the nitrogenase enzyme, sufficient for all the plants to harvest all the nitrogen they need in symbiosis with the microbes who have evolved to do that job. Now, that is not a good business model for the fertilizer companies. But molybdenum is an anion, which means it leaches when it rains. And if you got soil here that hasn't had glaciers in a while, you guys are south of the glacier line, right? You got weathered, worn soils. Molybdenum is an anion, it leaches out. Anybody who's selling you inoculant for beans and peas wants you to have a response, otherwise you won't buy it again. So they need to put some molybdenum in there for the nitrogenase enzyme to be able to work, because you can't just have the azotobacter and the rhizobacter. The microbes, without their 9/16, can't loosen that nut. There's one. That's just one element. How about cobalt? Cobalt's the center of a compound called cyanocobalamin. We call that, in common speak, B12. People heard about B12? If you're a vegan or vegetarian, you're told you have to take a B12 supplement because you're not getting enough for your body to function. If you don't get enough B12, you become lethargic or anemic. If you really don't have enough B12, you become dead. You need B12 to live. At the center of B12 is one atom of cobalt. Guess who else needs B12 to live? The microbes. 80% of the species of microbes that have been studied are B12 dependent. If you don't have cobalt in your soil, you can do all the cover cropping, you can do all the everything else, the compost teeing, all the little tricks you learn from all the people who are selling you stuff. But if you don't have cobalt, the microbes aren't there. They can't exist. What do you need? 4 pounds to the acre? So there's a whole bunch of different minerals that are necessary for what we call biochemistry, which basically means your toolbox has to have tools in it. If your tractor breaks, you don't just want the metric sockets. You'd like to have the imperial sockets. You'd like to have a bunch of different screwdrivers, some star bits, and maybe a few Allen wrenches. How about some pliers? Right? If you're a farmer, you want a full toolbox. Anybody? Bring out the half-full toolbox and have what you need not be there? So biochemistry is how nature builds stuff. And if you don't have the full suite of minerals in the system, nature can't build stuff. Remember how we talked about there weren't that many polyphenols in the carrots? The polyphenol is a big compound. It takes a bunch of different Allen wrenches, Phillips heads, flatheads, sockets to build a big compound like a polyphenol. If your soil doesn't have that full spectrum of minerals, you can't build those compounds. So minerals is a piece of the puzzle. I'm a big fan of rock dust. I think between basalt or granite and sea salt, like the continents are made out of granite and basalt. The oceans are made out of seawater. Basalt has 50 elements, granite has 35, seawater has 90. Like, who can corner the market on seawater? Anybody? There's too much out there, so nobody has a reason to tell you about how valuable it is. How about granite? Like, you can't really corner the market on granite. You can't really mark up the price that much because people will, I'll get my own. Like, as I understand it, mineral deficiencies are a massive issue, and they're easily addressed through sourcing naturally occurring materials from our lands and from our oceans. We can systemically address these mineral deficiencies. We don't have to keep adding them year after year. You need to fill the tank back up. It's been worn out. It's been emptied over the last 10,000 years, 200 years of agriculture. Once you bring that rock dust back in, fill the tank, you don't need to keep doing it. But if you don't have the minerals, you're going to be constantly having these system dysfunction dynamics occur that if you track them all the way back, go back to the biochemistry. The last one I'd like to talk about is life. If you just simply don't have the spectrum of species present in the ecosystem that are necessary for those biological processes to occur, they can't occur. Who's heard about St. Patrick and the snakes? Anybody know about this story? There's no snakes in Ireland because St. Patrick killed them all. That's a story. Actually, I think it was the glaciers during the last ice age that basically covered the whole island, and then when the glaciers melted, there was no way for the snakes to get back because there was an ocean in the way. But either way, there's no snakes in Ireland. But if someone was to bring back a boy and girl snake, there could be snakes in Ireland. How about this? If there's no mycorrhizal fungi in your field, we can debate why. It doesn't really matter. All that matters is there isn't. All you have to do is bring back some mycorrhizal fungi, and if it has the environmental condition, it'll establish and reproduce. So reestablishing microbiome, which I think the most efficient way to do that is on the seed, and letting the plant, when it germinates, be able to feed that gut flora. Who's heard about this thing called colostrum? Anybody? Colostrum? When the baby's born, after birth and before milk, something comes out of the mother's breast called colostrum, which is a prebiotic, it's a probiotic, it's evolved to help establish gut flora, right? You know about the fact that you can't digest your food. It's only the people in your belly that digest your food for you, right? Like, you can't live without them. You need to have your gut flora established at birth. A baby that doesn't get its gut flora established at birth is a colicky baby. A colicky baby is one that cries, that fusses, that doesn't sleep, that doesn't put on weight, that's a pain in the butt to have. Versus a baby that gets its colostrum, which basically nurses, sleeps, occasionally coos at you, poops, goes back to sleep. Anybody ever heard of or been around a colicky baby, or B, one that got its colostrum? They're night and day different. Has anyone here ever planted seed that was like orange or purple or a certain kind of bright color? Anybody? And you know why it was that color? Because it was coated with fungicide? So let me walk you through this concept. A colicky baby is one that cries like you can't sleep, it doesn't put on weight, you got to go to the doctor 4 times a week, all of a sudden there's complications. Because it didn't get its gut flora well established at birth. What's the best way to get a colicky baby? Besides don't give it a colostrum? How about a 10-day dose of antibiotics? If you gave a newborn baby a 10-day dose of antibiotics, you could pretty well guarantee it would be a colicky baby. if a plant at birth or germination is coated in fungicide, that effectively guarantees it cannot set up a well-functioning gut flora, you're basically promising yourself a colicky baby. Now, if you're a doctor telling every mother to give the baby a 10-day course of antibiotics at birth is a great way to get business. I mean, there's few better ways to get business if you're a doctor than to have the baby given antibiotics at birth. Yeah? And yet you willingly give every single one of those babies you put down at 36,000 per acre a 10-day course of antibiotics at birth, and you wonder why you need the insecticides and the fungicides, etc. Time's up. I used up my hour. Is that time's up? I can round it out. I could. I had a couple questions. Those are my 5 points. You need air, you need food, you need water, you need minerals, you need life. Almost all these things are free or near to it. If any one of them isn't present, you should expect the system not to work. I'm a farmer. I don't want to use inappropriate language, but I am not happy when farmers are being taken for a ride by people who are selling them things when we have the science and we know how to help farmers have a better quality of life, how to have farmers have a better impact on the land and have them produce food that's proper for people. Like, it bothers me deeply that we know these things and these things are not being told and farmers are not being supported in implementing them. So if I'm coming across too strong and too emotional, I apologize, but it really gets to me. And I'm hoping you guys can hear it and feel it. And like I said at the beginning, I teach courses. I taught this course around the planet for 17 years. It's on YouTube for free. If you just type in my name, if any of this has been intriguing and this hour's not been long enough and you just want a little bit more, type in my name on YouTube and there's a 12-hour course there for free. And there's all kinds of books, and our organization has recordings on our YouTube channel. There's so much more information. The information is there. We have to want it, go looking for it. People who are selling us stuff are selling us stuff. They don't have our best interest necessarily at heart. They're selling us stuff foundationally. In almost all cases, what we need, we don't need to buy. And if we do need to buy it, we need to find a local natural source for it. There are ways you can hack the system. There are things you can get here and there that are nice. But if you don't understand these basic dynamics and you just buy something and think that's going to be the silver bullet, you're missing the point. How to measure soil life. I mean, besides the nose, which is great, and the eyes, which you can look and see, what we were using in the lab was called respiration. Respiration, which is like, I think there's a thing called a Solvita. Solvita is a little kit. You can buy a little thing. Basically, we were just dry the soil down. You grind it, you weigh it out, you stick it in a box, you put a certain amount of water in, you keep it at a certain temperature, and you measure the amount of carbon dioxide that shows up 12 hours later or 24 hours later. So this is not a sophisticated thing. There's all kinds of meters you can buy. There's all kinds of expensive things you can buy. For me, it's much more about going out in the morning for a walk and being on the land, because that's, what do they say, the best fertilizer is the farmer's footsteps. If you're out there with your heart, if you wake up at 2 o'clock in the morning and you're like, oh my God, or you wake up in the morning and you're like, oh, whatever that thing is that strikes you, like, this has to happen. That's the truth. We are in touch with our land. We love our land. Those things that come to us are the answers of what the land needs. All indigenous cultures globally have taught us for millennia that we can communicate with nature and nature can communicate with us. And we're not supposed to talk about it here in the West because we only have 5 physical senses and that's all there is. But apparently, if you listen to anybody else on the whole planet, there's a bunch more going on. So if you're a farmer and stuff comes to you, listen to it, follow it. If you want to be a scientist, just do it in a corner and don't do it anywhere else and see if anything different happens. But if you can focus on these 5 things and do everything you possibly can to make sure they're present 12 months of the year, right? You can't just take 2 months off with life because it all dies, and then you got to bring it back. So we got to treat our land like it's alive all the time and set it up to succeed and find the least expensive, most natural things to get you there, because nature grows all year long without any help because she's getting these things going. So look to nature, look to nature for your model, for your teacher. Like I said, if anybody tells you something that differs from what nature does, that person's wrong. They may mean well. They may be repeating somebody else. But just because somebody said it, they may be famous, they may have a lot of money, they may have a really nice Instagram platform. Just because a human says it doesn't make it true. We have to realize where truth is and where truth isn't. Aluminum, barium, strontium, heavy metals, toxins, environmental pollutants. Are we talking about glyphosate, or are we talking about, okay, there's all kinds of things in the environment that are not good. Microbes, when they set up shop, as they establish themselves, they tie up heavy metals, they digest toxic chemicals, whether it's radiation or PCBs or dioxin or glyphosate, aluminum, lead, cadmium. If you've got a well-functioning microbiome, they will literally, after Chernobyl, they couldn't find radiation on the plants of the farmers that had good microbiome, like in the fallout cloud, because the microbes were eating the radiation for breakfast. I just saw a paper, like it was on Google News for like 4 days, about this fungus, which is like literally invading the Chernobyl nuclear reactor, like literally eating the radiation, like, yeah, digesting it. PCBs, dioxin, heavy metals, it's only when you've got a well-functioning microbiome that anything's going to be functional. Like, they're in charge, we're here in service. The more you can create that reality, the more they will digest stuff. Everything, any pollutant you want to think about. Microplastics, oil spills, the citations are there, the literature's there. Paul Stamets has done a bunch of stuff with this. I can direct you to all kinds of people where the papers exist, where this microbe can digest that, this microbe can tie up that. We don't need to worry about all the sciencey stuff. Humans lived for a long time without PhDs and lab coats, and they did well. What we need to worry about is making sure nature has what she needs. And then we can go about our life with our children and our families and God and culture, which is what we're here to do. We're not here to stress out and get all caught up in our heads. We're here to live life fully. And I think, we can easily get spun out in our heads and fearful. And fear is not love. Anything that we put our energy into that's based on fear is not bringing towards solutions. It's taking you off track. There's a whole other conversation there. Money, economic viability, the less money you spend, the healthier your system is, the better your production, right? If you're sick, you don't have a lot of energy to do much. If your plants are weak, they can't be that productive. You can kill the insects with an insecticide, but a plant that's digestible to insects is not a healthy plant. It's not going to be getting high quality yield. I was making my living farming 20 hours a week when I was doing it full time, part time. I'm not doing it at all right now except just to grow food for myself. Charging market rate. Because my cost of production went down, my economic viability went up. I didn't tell anybody about nutrition, flavor, aroma, nothing. I just said to my customers, I said, here, take this sample, stick it in the cooler, in the corner, I'll call you in 3 weeks. I called him 3 weeks later, like, who are you? I'm like, I'm the guy that told you to put that sample in the cooler. Like, oh yeah. Like, go get it. Pull it out. Like, what are you charging? You got a contract. If you produce better quality at a fair market price with a lower cost of production, my proposal is that's how you get economic viability. That's how you make a living. I'm not, we're talking about whether you're paying into part of the commodity system or not. That's a whole other conversation. Labs, there are people you can send samples off to for mineral analysis and stuff, nutrient analysis and stuff. My idea is, and it looks like it's going to be true, by 2030, enough people are going to have a sensor in their phone that the incentives in the whole supply chain will have shifted. So you can spend $200, $400, $500 a sample to get readings back, which will have 40 different numbers on them, which actually can't be converted into anything meaningful. So, I mean, if you got some money and you want to play around, that's great. What we're trying to do with this science project is to do the science, to find the patterns, to build the meters that make it so you never have to go to a lab. Let's use the labs for the purposes of science projects. Let's use big data and AI and algorithms to find patterns. Let's use the market to incentivize people to make meters so we can actually not have to get all those numbers and make all those complicated claims. It's a couple years out, is the short answer. I'm sorry, I could come down here in 2030 and I'll tell you, look, it's in your phone, but you already would have heard about it. So yeah, if you want to go spend some money on lab tests, go for it. I can tell you where to go if you want to spend money. But from a practical standpoint, I'm not quite sure what benefit you're going to get from it. All right, I've used more than my time. Thank you very much.